So this is the question I developed in the assessment part of the topic portfolio on AutoCAD. So what it is, the subtopic area of surface geometry, it is intersecting ductwork and pipework. So this is obviously ductwork, and I got my inspiration from Anderson's book, where there's a question of intersecting ductwork, and I just changed the components where I have three surfaces that need to be developed here. The reason why I thought it was, I think it's a good question, is because three surfaces are asked to be developed, and in three different methods as well. So we're not just, students are going to have to think of different ways to develop out the different surfaces. So the question is, a square section duct of 50mm side is being intersected by a rectangular duct B of sides 20mm and 30mm length, which is connected to another duct section C. The ducts meet at an angle of 60 degrees, and find and complete the surface development of the three duct sections. So what I'm going to do is complete this question, drafting it. As you can see, I have the solution here in AutoCAD as well. You can see the construction lines and how it was solved. So basically what I'm going to do is just talk through how it's solved, and I'll also rationalize why I picked it throughout. So this is just a printed out copy of the question I developed. So the pupils, after reading the question, they're going to have to identify a couple of pieces of information. The first being that in order to find duct A, B and C, obviously in elevation, duct A must be found in plan first, as we can see, because the ducts meet at an angle of 60 degrees. So in order to find 60 degrees and project it up, we need to find duct A in plan. So how this was done was using set square just at 60 degrees. So I'll show it here. I simply just stepped it out, construction line 60 degrees and then 30. Now how I got the size of duct A, well, it's stated in the question. It says a square section duct of side 50mm. So I just measured 50mm using the compass, and then obviously stepped it out on the 60 degree and 30 degree lines. So now that duct A is found, the pupils should project their points up into elevation. So obviously project them up, and we know, as stated in the question, the height of duct A is 80mm. So projecting all the points up, they should be able to identify that this line here is the back of duct A. It's not going to be seen, so therefore in elevation it's going to be seen as a hidden line. So the next step is, after drawing duct A in both plan and elevation, we now need to develop B and C, draw them out. So as we can see from the question, all the information of duct B and C is given in elevation. So therefore we're going to have to draw duct B and C in elevation first and then project down. So the first part is duct B. It's 20mm sides and length 30mm. So, and obviously stated it's 20mm high up from the ground level. So all that students need to do then is go up 20 in height, step it up another 20, which is the height B, and then over 30mm length. And that's how duct B is found in elevation. The next part is duct C, which is at a 45 degree angle to B. So students will draw their construction lines. So at 45 degrees, bring this across and this across the top. So how did I know where, how will pupils know where to stop this duct C? Well, it states in the question, which they must identify, that it's 60 mils high. So 60 mils from the ground up, and we know that that's the height of C. The next point is, so duct B and C are found in elevation now, and simply the most difficult part of this is probably bringing this point here down in elevation. The rest is just obviously brought down, whereas we know it's 20 mil side, so if the pupil measures up 20 and across where it hits it, we know that that's where duct B hits that part of duct A. So the next thing I'm going to do is just develop out duct A, and I'm going to do that now and then discuss how that is achieved. So now I've developed out duct A. So how was this achieved? Well, it's a very basic principle behind developments and envelopments. So all that was done was the heights were brought across and just extended along. Obviously this could be done a different way. It doesn't have to be brought across, but with room on the page and everything, this is the most viable way to do it with room, and it's obviously easier just to bring your heights across instead of measuring 80 mil and bringing it down somewhere else. So the heights are brought across, and obviously where duct B is, I'll get into that next. So what I did was 50 mil sides, so obviously there's 4 sides to this duct. I stepped it across on the height 4 and brought it up until it met. So that was the development of A. The only thing that where students might fall down is, I noticed some students may make a mistake of thinking this is their a side of duct A. That's a potential mistake, and also forgetting to put in duct B. So I knew to bring across, and obviously it's 20 mil side, so I went 20 over, and that's how I got duct B. Now this could easily be here or anywhere. I just decided to fold it out here basically the whole way around, but obviously the student could start with this point and flatten it out, either or. So the next step now is going to be developing out duct B. So now the development of duct B has been found. So all I did was from plan, it has to be found from plan because we need this point here. So I brought down our construction lines across. We knew that each side is 20 mils, so I stepped off 20 mils 4 times to get the length in total. So, and then I just started with this point here looking up at us. We obviously could have started with a different point back here or whatever, but I decided to start here to fold it out. So I just brought my points down, so we knew what this surface looking towards us was going to look like. Then the next is obviously the side, which is going to be square. We can see that in elevation as well. The next point is B. It's going to be just the reverse of this, looking underneath. And then the folded piece here, which comes around. Perhaps that's the only point that would confuse pupils here, is this part here. Perhaps they might continue it out larger. So that's the development of duct B. And finally, we're going to get our development of duct C. So that's the last part of this question. Now I've developed out duct C. So what I did was I got an auxiliary view perpendicular to C, which was at 45 degrees. So I projected my lines down, and I obviously, it can be done either way. I think in the AutoCAD I have this section here, but I projected this point up first. So obviously getting our heights. An important thing to note then is these heights are going to be obviously smaller than our 20 mil here, because we know what this is going to look like. So that's the end of the question. That's the 3 surfaces, the 3 ducts developed. So how can I rationalize given this question? Well, I think it's a good question because it's getting students to develop 3 ducts out in different ways and different methods. So it's testing their knowledge of surface development of ducts and transition pieces quite well because of this, because they have to identify the different ways that these ducts have to be developed out. Another thing is it also looks at their reading of the question, because they need to identify the key information. Some pupils may struggle to see that the ducts meet an angle of 60 degrees. They might not understand what angle this is at and how these ducts are intersecting and meeting each other. So I think there is some stuff that would perhaps confuse pupils in this question, and that's why I think it's quite a good question to have in surface geometry to give to pupils.